Okay, just continuing to work some examples. So solve the triangle. This time they gave us the information with no figure drawn. Okay, for those of you that it helps to draw, I would suggest that you sketch the figure as best as possible and then move forward. Okay, so let's just sketch as one. If it helps you to do this, then fine. If not, then work it from here. Angle A is obtuse, so if I draw one, this one's going to be an obtuse and the other two are acute. It doesn't matter if I call this one angle C or this one angle C. What matters is that opposite of this is going to be side B, which is what value? 6. Okay, and opposite of angle C is side C, which is value 9. And now we basically have that labeled, and we can see that we have a side angle side, and we can use laws of cosines. So what we're going to look for first is the missing side, which is A. Good. So let's use our law of cosines and solve for A. Plugging in our given information first of all is just going to be A squared is equal to, all right, B we know, C we know, 2 times B times C cosine of 130 degrees. And this nicely gave us everything for this formula just strictly from here without needing the visual. So some of you may not need that at all. Square root this entire thing. So A is approximately, that's going to be 36 plus 81 minus all of this. It's approximately 13.65 after you take the square root. Okay, so we have side A, side B, and C now. We have our missing. The next thing we want to do is solve for our other missing pieces. But once we have this information, let me go ahead and put A in over here. So A was 13.65. We could actually use our law of sines now if we wanted to. So for example, if we had, let's just think back to our previous lesson. So sine of angle B over side B and sine of angle A over side A. We could set this up and solve now. We have enough information to be able to find our angle B using law of sines if we wanted to, just so you see another example. So here, let's plug in our information. Sine of angle B, we don't know that yet, but what is side B? 6. Good. Sine of angle A, well, we know angle A, that's 130 degrees, and it's also a given value, over side A. Okay, so what did we do here? We would cross multiply, right? Algebraically, we would cross multiply here, and we would get 13.65 times the sine of angle B is equal to 6 times the sine of 130 degrees. Divide both sides. We want to get B by itself, angle B, so we're going to divide both sides by 13.65. Those will cancel, and we'll get sine of angle B is equal to our right hand side, and at any point you could put this in the calculator, but just like we did before, to get angle B by itself, we'll take the sine inverse of each of these, and that will give us angle B is approximately 19.7 degrees. And of course, when we're just finding our last angle, which is what, angle C, I'm going to take angle A, which is 130 degrees, add angle B. We're going to determine angle C, but we know all of them together should add to 180, so C is approximately 30.3 degrees. So initially, to start this, we would use law of cosines, but we can also have the option, once we know the given information, we can also apply our law of sines. So you have some options there to be able to solve Of course, we also have options for our last angle, but this is just my method that I prefer. So lots of options here. Okay, I think we're going to wrap this up here. So we're just going to solve the triangle. This one's given, not given a figure. And this is clearly a, what kind of triangle? Side, side, side. So all three sides are given. So this one we want to use law of cosines to start. Now it doesn't matter which angle. I'm missing capital A, capital B, and capital C, which are all of our angles. So I'm just going to choose to start with A. Now once again, if you'll let me just come to cosine of A is equal to, this is once we solved for cosine of A. And we've done this multiple times. So, okay, so we're here. Now let's go ahead and plug in our given information for this problem. So b squared, so that's going to be 4 squared plus 5 squared minus 3 squared over 2 times b times c. (16 plus 25 minus 9 over 40) simplifies to what? 4/5. So we have cosine of A equals 4/5, and to get angle A by itself, we'll take the cosine inverse of 4/5, and we'll find out that A is approximately 36.9 degrees. Okay, next one I'm going to choose to solve for is going to be cosine of B, and we've previously solved for that. I'll even like toggle back to where we did that right here, cosine of B. So if you'll allow me, I'm going to pull this over there, and we'll just start from that position. So cosine of B was equal to a squared plus c squared minus b squared over 2 times a times c. Let's plug in. So a is 3, c was 5, 2 times a times c, 9 plus 25 minus 16 over 60, which is 3/5. Cosine of B. Cosine of B is 3/5, so when we want to find angle B, take the cosine inverse of each side, and angle B is going to be approximately 53.1 degrees. Once we have A and B, then we're just going to say, we'll jump up here. So angle A is 36.9 degrees, plus B was 53.1 degrees, plus angle C, which we're looking for, adds to 180. So C is approximately 90 degrees. Just a little bit of practice to set up an application problem. So if we're presented with this, a golfer hits an errant tee shot that lands in the rough. A marker in the center of the fairway is 100 yards from the center of the green. While standing on the marker and facing the green, the golfer turns 115 degrees towards his ball. He then paces off 40 yards to his ball. How far is the ball from the center of the green? So all I'm going to practice with you right now is actually setting this up. So first of all, let me just, if I do a, let me just start with this triangle. And of course, this is not going to be to scale. Alright, so let's just say if I let this be my marker. Okay. And we'll put our flag over here. All right. So how far is it from the marker to the flag, to the fairway? What did it say? 100 yards. So basically, I would label this side right here 100 yards. Okay. And let's say this is where I'm standing. This is my marker, and let's say my ball is over here. All right. So what they want to know is how far is the ball from the center of the green. So what question are they asking? Do they want to know this side or do they want to know this side? Yeah, they want to know from the ball to the green, so they want to know this side. We're looking for this. Now, do I know the other information? Do we know how far it is from the marker to the ball? Yeah, well, he paces off 40 yards to his ball, so we do know this side as well. Now, your triangle didn't have to be set up this way. You could have had it in a lot of different directions, but basically you have a marker where you are, a ball, and a fairway, and then you would just use your information to plot out. Now we know two sides. What else do we know? If I'm standing here and I turn 115 degrees, then we also know that this angle is 115 degrees, right? So we have a side angle side situation here, and we can use our law of cosines to set this up. We can call this side A, we can call this side B, and be looking for side C, and then you can work that from there in the same manner that we've done the previous one. So the practice in this was just how can we set up an application problem, and if you see one in that looks like this.